This is FRM Part 1, Book 4, Valuation and Risk Management, and the chapter on returns, spreads, and yields. Of course, we're inside a series of chapters on fixed income securities, and we're trying to determine the relationship between and among all these different kinds of variables. The most important of which, of course, is the price and the yield relationship. And so we'll get into that some more. Let's look at these learning objectives. We'll do some simple math to start off. We'll look at the difference between gross and net realized returns. And then we'll talk about an important concept. What is the spread of a bond? We'll talk in a couple of slides about the yield to maturity on the bond. Then we'll go back to this concept of spot rates that we did in the last chapter. We'll talk about coupons, and then we'll try to figure out how you can compute the profit and loss for a bond investment. Let's get started on gross versus net realized returns. All right, so the gross realized return, gross kind of meaning like total return, realized meaning that you've actually bought and sold the asset. And so it has two components, the capital appreciation, right, increase in the price of the asset, and any income received while holding on to that investment. So with a bond, what do we know? Well, we can buy low and sell high, and we can receive coupon payments. Remember, coupon payments are probably made every 6 months. And so that gross realized return, there's a formula that I'm guessing you guys know from previous conversations. And so all we're going to do is say, if we buy something for 100 and we sell it for 108 and we got a $2 coupon somewhere in the middle, there's that ending value of 108 plus the coupon of 2 minus the beginning value of 100 divided by the beginning value of 100. So what is that? That's 110 over 100. That gives me a gross realized return of 10%. Now, of course, sometimes there are other things involved in an investment. Then let's just take one example. Suppose that when we originally bought that bond for $100, that we borrowed it. We could have borrowed the original 100, or we could have borrowed $50 or $10 or $90. We could borrow any amount of that original purchase price. So let's suppose that we're paying 1% over 6 months, and so all we're going to do to get the net realized return, is do the same thing that we did up above, but then subtract out the cost of financing. And so we'll divide that by 2, since that 1% is an annual rate. Here we can quickly do some math. Let's see, we bought a bond 12 months ago for $1,000, currently selling for $10.60, paid a coupon of $20 6 months ago, and that was reinvested. That's an important concept. And then today the bond paid a $20 coupon as well, right? So the purchase price was entirely financed at an annual rate of 1%. So what is the net realized return on the bond? Well, let's go ahead and figure out what the gross realized return is. And so we're going to take the $1,000 that we originally spent. We turned that into $10.60, right? So we made $60 over 12 months. Plus, we got $20, so we'll add the $20 in there. Plus, we got $20, and then we reinvested it for a 6-month period. And so if you do all that, and notice down in the second to last circle point, I have the gross realized return in different colors. So that gives you about 10%, and then we subtract out the 0.5% financing cost, and that gets us down to 9.52%. Spread of a bond. Let's go ahead and define the spread in this context as the difference between its market price and the price computed according to spot rates or forward rates. Remember, in that last chapter, I showed you guys how to compute the present value of a bond using spot rates, and then present value of a bond using forward rates, and they turn out to be the same price. Of course they turn out to be the same price. Now, in this context, the spread is going to help determine whether the bond is overvalued or undervalued relative to the yield curve. Let me just remind you about that yield curve that we talked about in the previous chapter. Yield curve is a picture of the relationship between time to maturity on the horizontal axis and yield to maturity on the vertical axis. Now I've got that good formula there in the middle, that blue formula. The market price is equal to a whole bunch of stuff, right? We have in the numerator the fixed coupons, there's the two C's, and then the principal amount. And then in the denominator, we're going to discount those by using those forward rates. And we did that in the last chapter. Now, the concept of the spread can be incorporated into that formula by saying something like, okay, let's go back up to that first block point. The spread is the difference between the market price and the price computed according to the spot rate or the forward rate. So look in this bottom formula. What we're going to do is we're going to put that market price on the left-hand side of the equal sign, and then we're going to add a spread. There's the plus S in red in the denominator at the bottom. We're going to add a spread to the forward rates to force those present values to be equal to the market price. And that way we can determine whether the bond is over or undervalued. Of course, if S is zero, right? If S is zero, then the market price and the present value computed using spot or forward rates, they have to be the same number, right? So if there's no spread. Now, this concept of yield to maturity is one of the original ones that you discuss when your undergraduate finance professor talked about bond pricing. And so yield to maturity, I always tell my students to think of the yield to maturity as the required rate of return on the bond. And it's a little bit more complex than that, but I tell my students to think of it in this way. Look, the borrower, whether it's a government or a corporation, comes to you as the bondholder and says, hey, lend me a bunch of your money, I'm going to go do something with it. And you say to that borrower, you're the bondholder, you wag your finger and you say, look, you can only have my money if you pay me this yield to maturity. That's your required return on the bond. But it also implies that that's the return that you're going to earn only if you hold the bond until it matures, because that yield to maturity, which we'll see here in just a second, depends on receiving that $1,000 at maturity and all of those coupon payments. Now, mathematically, the cool thing about yield to maturity is that it's the fixed income securities IRR, that internal rate of return. So I always teach my students how to use the IRR button to compute yield to maturity. So there's the formula in the middle. We've got the P on the left-hand side. That's the bond price. And then we have the C1 and the C2 all the way up to CN. And remember, lots of bonds are 10 years or 20 years or 30 years, but there are some bonds that have been issued for 50 years and 100 years. So that N can go way out into the future. And then we're going to divide by 1 plus that yield to maturity. So notice what we're doing here. When we use the yield to maturity to compute the price of a bond, we're assuming the yield to maturity is fixed for 10 or 20 or 50 or 100 years. Now, of course, that's the formula for computing the yield to maturity. And if you read textbooks will always tell you to do the trial and error. They'll say something like, oh, pick 8.2%. And put that in there and see if it turns out to be the price of the bond. And if it's right, then your first guess was correct. And then guess again and guess again and guess again. Of course, I never require my students to do that. And most textbooks then will have a little thing on the side of the page saying, oh, by the way, you can use a financial calculator and here are the inputs. And that's what I have on the bottom arrow point down there. You use the I/Y function or the IRR function. Now, that's, of course, for coupon paying bonds, but for zero coupon bonds, you can have a shortcut formula there. And there it is, face value of the bond, which is always going to be 1,000 over the current price of the bond. And remember, zero coupon bonds will always sell at a discount, and then you raise it to the 1 over 5 if it's a 5-year bond, or 1 over 50 if it's a 50-year bond, and subtract 1. Of Of course, you can still use your 5 time value of money buttons on the calculator. The payment would just be 0, and you still solve for the interest rate. Boy, seeing this formula there in the middle of the page takes me back to my first days as a young PhD graduate, when I used to make my students memorize this formula and compute present value of the annuities there. So there's the formula. You just take the annuity, there's the PMT, and you multiply it by some a little bit rearranged time value of money factor to get the present value. Of course, you can just use the financial calculator to do it for you quickly, but that's the formula that the financial calculator uses when you hit, let's say, 10 for payment, and then you hit present value to solve. Now, a perpetual annuity is an annuity that goes on forever and ever and ever and ever, and the good news is that it's a really simple formula. You just take the payment, like 10, and divided by R, which is, let's say, 10%, the decimal form of the interest rate, and you get $100. And so my students are always amazed, at least some of them are amazed, that you could save $100 today and promise to pay me $10 every year forever and ever and ever and ever if the interest rate is 10%. By the way, that's a pretty restricting assumption. But then I simply explain it to them. I say, look, if you have 100 today and you invested at 10%, a year from now you'll have 110. You take out the 10, you'll have 100. You pay me the 10, and you can do this over and over and over again. Long after I die, my children can receive this. Long after my children die. And of course, the assumption is that the interest rate is fixed at 10% over an infinite time period. Now let's go ahead and see about this relationship between this yield to maturity, which we just talked about here a few moments ago, and relate that to all of our discussions on the spot rate in the previous chapter. Now here's the big difference between the two. Although both of them can be used to determine the fair market price of a bond, that yield to maturity is constant. I've been saying that for the last few minutes. However, the spot rate is going to vary from one period to the next, because the spot rate, remember, is the yield to maturity on a 0 coupon bond for 1 year. And then the 2-year spot rate is the yield to maturity on a 0 coupon bond for 2 years and 3 years and 4 years and 5 years. And of course, those spot rates reflect all sorts of variables. But here, the spot rate is the truer measure of the fair market price when the rates are believed to, rise and fall, which of course, that's what we know. We know interest rates rise and interest rates fall. Now, here's the thing. Given the bond's cash flows, and for a fixed rate bond, that's pretty easy, and then determining relevant spot rates, which is also relatively easy, then you can easily calculate the price of the bond, and then you can work back to get the yield to maturity given the price of the bond with those spot rates. Now, of course, when the borrower issues a bond, whether it's the government or a corporation, the borrower sets that coupon rate. Remember, this is an explicit promise made by the borrower, just like you and I make an explicit promise to pay off our mortgage. I promise to pay interest, and I promise to pay principal. Well, the government and the corporations, they do the same thing. They promise to pay interest. Now, this is an interest-only loan, right? Coupon payments are made during the life of the bond, and then the maturity payment is made at the maturity date. I mean, think about how tough it would be if we spent $300,000 or $400,000 on a house and only had to make monthly interest payments, and then after 30 years we'd have to pay back that $300,000 or $400,000. But that's the way it is with bonds. Now, remember, what these borrowers try to do is they try to set the coupon rate to be identical to the investor's required rate of return. They try to. The problem is there's always a lag between the time of when that coupon rate has to be determined, and then documents are filed with the SEC or other government bodies until the actual issue date. So there's always a time lag. Now, what that means is that the coupon rate, even though it's fixed over the life of the bond, is going to be dependent on the required return at the time of issue or around the time of issue. And so we know the yields go up and they go down. So there's going to be lots and lots of different coupon rates out there, even with bonds that have similar maturity dates and similar other kinds of characteristics. So look at my first block point there. The coupon effect describes the fact that fairly priced bonds of the same maturity but different coupons are going to have different yields to maturity. Of course they're going to have different yields to maturity. Just look at those 5 buttons on 5 time value of money buttons on your calculator. If you put a different payment in there and solve for I, you're going to get a different one. All right, so the implication is that yield is not a reliable measure of relative value. So even if fixed income security A has a higher yield, it's not necessarily a better investment because it might have a giant coupon payment. Now here's the other point about this coupon effect. Look at the second block point. Bonds with smaller coupons are more sensitive to interest rate changes. And then let's start at 10% and then go down to 8 and 6 and 2 and then 1. If you get to 0, if you get to a 0 coupon bond, they are very sensitive to changes in yields. Now, of course, this coupon effect can be summarized by the bond pricing implications in that if the coupon and the yield are not the same number, then the bond is either going to sell for a premium or a discount. So if the coupon rate is greater than the yield to maturity, the bond will sell for a premium. If it's less than, then it'll sell at a discount, and if it's equal, it will sell at par value. So here's the deal for fixed income security managers. If a bond sells for a premium, then over time that price has to fall down to its par value. If it sells at a discount, then it has to rise as it approaches the maturity date. This is known as pulling to par. And let me say one final thing here. I always tell my students that the following. Look, let's suppose the yield to maturity is 10% and the coupon rate is only 8%. So remember the whole wagging of the finger. So the bondholders are saying, look, we're only going to pay you, we're only going to lend you our capital if you pay us 10%. Well, how can you get 10% out of a fixed income security that's only paying 8%? Well, what the bondholders do is they reach out and they squeeze the bond to squeeze an extra 2% out of it by paying less for the bond. Of course, this is a bond that has to sell at a discount. Now let's go ahead and talk about how we can buy low and sell high and what the components are. So the total price appreciation of the bond can be determined by just this simple formula here. Forget about what's in parentheses. The price at time period t plus 1 minus the price at time period t, right? I think in the earlier example we had $1,000 and then we had $1,060. So that total price appreciation was $60, right? The difference between those two. But let's go ahead and talk about what's inside the parentheses. So let's go over to the left-hand side of the minus sign. So this is what we know today. This is the price today, time period t. Let's suppose that's today. And that's given an R of today and an S of today. And that R is the term structure, and then that S is the spread. So last chapter, we talked at length about the term structure, the slope of that yield curve. Remember, most times it's upward sloping. And then we talked a little bit today about that spread. And so the total price appreciation depends on the price today, which is a function of things like term structure and spread, right? And then sometime in the future, at time period t plus 1, we have a new price. What did I say? 1060. And that's the result of a new yield curve, right? Could be steepening, could be flattening, and a new spread. So notice that that's really, it looks a little bit more complex than it is. Really what we're saying is that we buy a bond today with this given set of economic conditions, and then we sell it tomorrow with a different set of economic conditions. And remember, I mean, the basic idea is that if the yield goes down, then the bond price is going to go up. And just the opposite is true. But let's go ahead and look at these three components of price appreciation. And so here's what's known as the carry roll down component. And this is the price change that results from a deviation from the term structure to the expected term structure. So notice what we start with. Let's go to the left of the minus sign. Here we start with today's price given the term structure and given the spread. But the carry roll down component then is going to be the result of the difference between what we expect that term structure to look like, time period 1, t plus 1, versus what we expect, versus what we know it looks like today. Now the rate change component, this is what I was talking about just a second ago, but let's formalize it a little bit more. This is the price change that results from interest rate movements from the expected term structure to the term structure that will actually exist, right? So this is just a difference between, all right, I expect that today in volleyball practice that my son is going to have 10 spikes, right? Well, when he goes to practice later today and he comes home and has 14 spikes, and he'll say to me, hey, Dad, you only thought I was going to have 10, but I had 14. And then finally, the spread change component is the difference between what we know that spread is today. Let's go back to that formula. We're adding a spread to the forward rate versus what it's actually going to be at time period t plus 1. So you have those three components: the carry roll down, the rate change, and the spread change. And that should make perfect sense based on that formula up at the top. And that's really not a formula. It's just that's just kind of an establishment of a relationship. All right, let's talk about some assumptions here that may or may not be too restrictive. Unchanged term structure, unchanged yields, and then realized forward. So the return of a bond held to maturity is the same as rolling the investment one period at a time at the forward rates. Now, in reality, some forwards are going to be realized above or below those initial forwards. And I think that takes us through this chapter.